Production and filament destabilizations were lower, we've got visibility of the incoming southern coronal hole. And if anything today, let's watch the sunspots as they begin crackling again this morning. The big story in space weather is the first proper CME impact of the sunspot cycle. Right side of the white chart shows the simultaneous shock-driven telemetry changes, key to this one being the maximum speed of less than 500 kilometers per second, which is barely in the moderate category, but still enough to cause a global shift in the magnetism, little perturbations all over, and induced ground currents at low levels, detectable but nowhere near scary. In the early morning hours, we climb to KP4, geomagnetic instability, and may creep up a bit higher into storm conditions as the day wears on, but again, minor storms as expected. Now the first special report. On May 7th, an M-class solar flare erupted at the northeastern limb. While the CME was not fired at Earth, the X-rays go out in all directions, and indeed, those bathed the Earth's upper layers, causing excitement. Occurring in the 1700-hour UTC, the flare energy was clearly visible in the polar cap potential and the field-aligned currents. But more importantly, the region under the sun at that time was right here. This UV exposure map does include cloud blocking, but it shows pretty well where the flare energy went to the ionosphere, confirmed by the D region absorption signatures. And at that point, we know the global electric circuit has been surged. The first thing that will happen is the higher energy up top will take the high pressure column down to the ground where it can find a way to move laterally. The high cell in the flare ionization zone was right over the United States at that time, feeding into the convective atmospheric potential energy in white, which split towards the North Atlantic storm and into Texas and Mexico. This all happened in a span of moments, as our book details, and as we've recently seen with those rapid forcing studies using the global electric circuit. By the way, the solar flare and energy surge into these regions occurred immediately before the Texas pipeline was allegedly attacked. Coincidence and timing, I'm sure. But that energy also continued to the edge of the convergence and flipped on the earliest tropical storm ever recorded in the East Pacific. Andres formed in the wake of the ionization, one day later as the energy needed to begin coming back up at the end of the line to complete the circuit. You can read a ton about solar forcing of tropical activity in our book. Looks like this sunspot cycle is off to the same start. But folks, as the energy came out in the Pacific, it also wanted to do so along the convergence line, which you can see running up the line of the pipeline that failed here. Coincidence again, I'm sure. That is where the energy is most dynamic and scariest, by the way. It's confirmed by a super lightning event one day later in the Florida Panhandle as the convergence surged over that area. Lightning blasted a road so hard, it sent chunks flying through a truck windshield. Flare, ionosphere, global electric circuit, large-scale system failure, tropical storm, major lightning. That'll about do it. Now let's move on for a little brain break with some lighter stories. We're watching blood echoes in this region as the others around the Pacific have had their surface realizations. Not this one yet. Super cool story about Mars and how its volcanoes may have been active about 50,000 years ago. More than a tiny change from their previous timeline and suggesting a more dynamic system for both geologic activity and Mars habitability. Titanic search for wandering black holes with some of the biggest names from the biggest organizations. I'll save you some time. They didn't find any. Meanwhile, who the heck is this? 103 pages of dark matter smacking beauty that includes not only the failures of the searches, but the science seen elsewhere that hints at another reality. The anisotropic nature, the dynamics. I'm still making my way through this one, actually. Up next, folks, we've got the definition of a megaflare. Seeing fit to split the previous supercategory of superflares, they have said that the flares lower than 10 to the 36 ergs should be called the superflares. Above that, they should be considered megaflares. Our sun is not capable of megaflares. Even the solar micronova is unlikely to be as big as some of the flares we've seen. But either way, the cosmic blast scale, also in our book, might need a bit of adjustment here. And that brings us to our second special report. The current sheet system, wide and undulating in close, forming more waves as you go out until the system folds up on itself in bunching patterns. We've more than shown the theory and observations of the waves, including in our own galaxy. Now let's see how big each wave actually is. It's another diamond from Voyager, where we learn more about the interaction of those smaller waves. The rotation-driven Parker spiral undulations separating the galactic magnetic reversal are tens of light years long, and that sounds about perfect. In the galaxy, the visible spiral arms are about 3,000 to 5,000 light years thick. The ones we're focused on here with the galactic magnetism are about 100 times less wide, meaning there are likely a few hundred ripples between us and the center of the galaxy. Lastly, a tiny nod towards what happens when the sheet hits. This one discussed the polar cap patch and electrodynamics of the sun sheet hitting the Earth. Of course, much of this is quite scalable. The end result when it hits the sun is a solar micronova. Okay, I think that'll about do it for now. Get all of our books and more 10-year anniversary sale at otf.sells.com, where you can also support the future of the community meetings and events by getting a founder's package for Observer Ranch, access to the first event, founder status,